All right, get your notes out. So, over the weekend we had math competitions here. Sophia and Ksenia was in this class, was participating. Winston's supposed to show up. He overslept. Anyway, so it actually went pretty well. I mean, we didn't like a pre-calc didn't do great, but it was okay. It's all about experience. He sold. Kind of upset about that one. All right. So what we're gonna do is we're gonna talk about graph sine of x. Y equal to sine of x. Now you're gonna be like, well, how do you graph y equal to sine of x? There's no, I cannot plug in 1 or 2 or 3 or 4. But it turns out that I can plug in unit circle values. Okay, so what I'm gonna do is I'm gonna start plugging some values that to show you what happened. So I'm gonna plug in x and y. X is the input, y is the output. Can I plug in, I start with 0. What is sine of 0? What is it? Oh, you guys will fail. Sine of 0 is what?
Y is zero is negative 1. I don't know.
It's y or 0. Zero.
So lost. Wouldn't it be no, it's with one.
Yeah. Y is 0 here.
No. X is 0. What is y?
It's pi or 0.
All right, the answer is 0.
Bruh, he said that.
Go back and look at unit circle. Your radians 0. What's my y value? All right. Can I plug in, let's say, pi over 6? What is sine of pi over 6? 1/2. Thank you. Oh my god. It's like something just left for you guys.
Over the week and everything like.
Somebody's out the door. Somebody get the door. No, I don't know. Don't give it to him. That's my new eraser.
Not my thing. It's fine.
It's a white one. That's even better. Okay, so I can plug in the next value. What is the next value? Pi over 4. What's pi over 4? Square root 2 over 2. Those of you guys don't know what's this, this is 0.5. This is 0.707. Because square root 2 is 1.414. So therefore 0.707. What's the next value I can plug in? Pi over 3. Okay, so if I plug in pi over 3, that's going to give you a square root of 3 over 2. That's around 0.8 something. I don't know. Somebody who's calculator told me what is it? 0.8 something square root of 3 over 2. Oh, I forgot. Can somebody figure out for me?
Divided by 3. Oh no.
Square root of 3 divided by 2.
Square root of 3. 0.7.
No.
What?
A66? She says A66.
Oh no, 0.8. Yeah.
Yeah, 800.
Thank you, Nelly. So what's the next value I can plug in? No, you dumbass. Pi over 2.
We both done it now.
Pi over 2 inside unit circle. That's gonna give you what? 1. Good. All right. I'm a continuous plug in different value. What's the next value I can plug in? 2 pi over 3. So what's 2 pi over 3? Square root 3 over 2. That's roughly 0.866. Is that okay?
Yeah.
And plug in 3 pi over 4 is what? Square root 2 over 2? 0.707. If I plug in 5 pi over 6, what will happen? 1/2? Good. So that's equal to 1/2. Is that okay? 0.5. If I plug in pi, what am I going to get? Winston.
Zero.
I'm out of it today.
You're super excited.
Do you see how I sigh? Sigh. That's like when my son goes like, sigh. That's a word. Doesn't matter. On top. Or like gulp. They take an expression and they translate it to a word and they speak that word. Huh?
I like that.
So annoying. All right. So obviously you're gonna get some type of value, and the value is gonna fluctuate going from. Wait, where are you going? What's your next period? Okay, good.
Dang, Mr. Anything not good enough for you.
All right. So obviously that this is some type of x coordinate, right? Sorry. Let me start with there. That's gonna be some type of x coordinate, and we're gonna break up to 6 sections. So this is gonna be pi over hold on. I'm gonna give you this is a pi over 6, and this is a pi over 3, and this is pi over 2. Do you know why that is? Because that's a 30 degrees. That's 30 degrees, 60 degrees, 90 degrees. And I'm gonna give you another value as here is gonna be another 30 degrees, so 2 pi over 3, and 2 pi over 3, and hold on a second, there was something wrong. My bad. No, there's something wrong. So hold on. 30 degrees, 60 degrees, 90 degrees. Okay, so this is gonna be, wait, 30, 60, 90, 120, 150. So 150 is what? 5 pi over 6. And wait, hold on a second. That doesn't make sense. Give me a second. 30 degree, 90 degrees, 2 pi over 3. The problem scale is different. Sorry, I'm redo this again. Okay, so I'm at the things that scale is a little bit different. So let's just say this is gonna be pi over 3, and that's 30 degree. So the middle is pi over 4, and then so pi over 3, 2 pi over 3, 2 pi over 6. So it's, okay, 3 pi. So this is pi over 2. And then another 30 degrees. So is what? 2 pi over 3, and then 5 pi over 6, and then wait, that is something is off. I might
7 pi over 6.
no pi.
Yeah, good. 30.
Okay, pi. Okay, that's fine. All right, so what we're gonna do is we're gonna use this as a 1. So first it's gonna give you this, right? And pi over 4 is right between pi over 6 and pi over 3, so that's kind of tricky. But we know at pi over 2 it's gonna be like this at 1. And at here it's gonna come back, but at 2 pi over 2, at this it's gonna be 1/2. So it's gonna form a curve. It's gonna form like a curvature here. Okay, I'm gonna continue as going. So I'm gonna say 7 pi over 6, 4 pi over 3, and 3 pi over 2, and then 3 pi over 2, and then next one is gonna be 5 pi over 3, and then 11 pi over 6, and then 2 pi. So what happened is it's gonna going from here to -1. So -1 is right here. So this is gonna give you 1/2. So it's gonna, I'm gonna use a blue line so that way you see. This is a blue line here. And it's come back. So this is called, and there's a name for it. I don't know how to spell that, but it's sigmoid graph. I don't know how to spell it, so I'm gonna look it up. Somebody look it up. Yeah.
What's the numbers after 3 pi over 2?
5 pi over 3.
Can you zoom in a little bit?
Sure.
Again?
Sigmoid graph. SINGNOULD, something like that. How to spell it? I don't know. Let me look it up. It's just a
sigmoid.
what? Hold on, let me look it up in a second. Not sigmoid, but anyway, this is how to spell it here. Let me look up for you right here. So this is the graph that we come up with.
Mr. Yale? So is the thing on the y the -1?
What?
Where it reaches 3 pi over 2, it's -1.
Yeah. Okay, so this is the actual graph. So this is the it's right here. SINUSOIDAL. It's basically a sine graph. I don't know how to spell, so this is what it is. Okay, so there are two things happen. One is, do you realize that's based on the unit circle? Do you see that's a circle? The y value of the circle is based on the height. It's called, according to AP exam, is the vertical distance, the vertical displacement away from the x-axis. So if I just pause it right in this moment, let's say if I pause it anytime like this, oops, oh, it's paused here. So if I just pause here, do you see the height is based on the y value of the unit circle? I just extend that line all the way to the other side, and then based on that, that's gonna be the height. Is that okay? And if we go backward, do you see? Is it based on the y value of the unit circle, which is the sine graph? Does that make sense or no? No? Okay, so this is the two-dimensional one. I'll show you the three-dimensional one.
How'd you put that in?
Actually, I can copy and I can put on the group chat. I don't know how to put on group chat, but I can do that here. So that way you can play with it. This is actually kind of interesting. Do you realize this is a unit circle? Okay. Do you realize that if I play the height, do you see that? It's based on the y value of the height. To channel, let's just say pause right here. Do you see the y value of the reference triangle is based on the height of that to build that the sine graph? Do you see this is connected? See this is based on this height of this triangle, the reference triangle. Is the y displacement. If the y displacement, this one we get it from value. For example, this is probably like a 2 pi over 3. Sine of 2 pi over 3 is going to square. Okay, Tanisha? Yes, it's go up to 1 because unit circle is going to 1. Is this okay? Now, if you don't understand this, I'm going to show you. It's part of unit circle, so I'm going to go look it up something. I'm going to go to YouTube. And we're going to say Fourier transform, which is Fourier transform of sine. Fourier. F. Wait, it's Fourier. There you go. Let me see if I can find it. It's a really old video. It's three-dimensional graph. Let's start with a K. K something. I cannot find it anymore. I used to have that video. I don't see it. Okay. All right. Don't worry about it. But anyway, Fourier transform of Fourier transform. Maybe that'll come out. Oh, this one. There we go. So this is kind of so you're gonna look at the other side. This is actually the unit circle part of it, and you're gonna see what is unit circle. You're gonna see it in a second. See, this is a sine graph. Sophia, are you paying attention?
It might be genetic.
It does. This is the unit circle right here. Is that the radius? The radius is not 10, is 1. So this is the unit circle part. You basically take all the y value, put it in term of a three-dimensional stretch. And then you can flatten it. Once you flatten it, you're gonna get this shape right here. So this is a sine graph. This is a graph that we generate. So I here it's 0 to 2 pi right here. This is a 4 pi. This is a 6 pi. So each time it gets shared, it's gonna be this. They can compress or expand. So let's say this is 1/2. This is called amplitude. Most of you guys need to pay attention. This is amplitude is 1/2, then it's gonna go 1/2. They can have a shift as well. This is gonna be plus pi. That means the whole graph shift left pi units. You can have increasing the frequency by divided by 2 inside. It's called horizontal stretch. We're gonna talk about all this. Just gonna give you an overview of this. You can add 2 sine graph, and if you add 2 sine graph, the graph's gonna be like something like this. Now you're gonna see something that's really cool later. It's called Fourier transform. It's actually basically you can add multiple sine fractions. So I can actually come up a sine function that exactly same as your heartbeat. I can reciprocate a function that is gonna be like your normal heartbeat. That's just for example, you're not exercising, it's just flat out. Like you just sit there, do nothing, that normal heartbeat. I can come up a mathematical function that imitate that. Not only that, I can actually produce sounds. So that's how AI come up with the sound. Like you saw, if I want an AI sound like a 2-pack, then it's gonna be they using the sound of they using the 2-pack's actual voice. They come up a function. So every word that you speak can be sound like 2-pack. Huh? Yeah, it's some type of apps that they can control, and they basically use a mathematical function. So if you see this, right, this is just a normal function has some type of shift. Now you're gonna see this still normal sine function. If you add more function to it, let's see, I'll show you. Like if you add more of different things, that's gonna create. See this start looking like a heartbeat now. It's basically adding all different kind of functions, all the sine function adding together. You can compose, you can imitate anybody's voice because sound is a wave. Actually, in physical chemistry, which was I studied chemistry, you can study how element is interacting with each other, how their vibration works. Okay, so and this will get more complicated if you add more sine functions. And the graph's going to look a little bit different each time when you look at it in a sideways perspective. If you add more functions. It's really cool. You're going to be like, I don't know why this is cool, but trust me, it is very cool because later I'm going to show you there's a person that uses sine function, a combination of sine function to draw certain things. So you can add different kind of sine, different amplitude, different everything. You can add it to the sine functions. Now, what happened is somebody else did something different. So, do you guys know the cartoon character called Simpson? This one. So somebody come up with a function that they can draw a Simpson diagram in one stroke. Yeah. And this is 16 years ago. It's not started yet. Sorry, it's not started yet. Oh, starting. all different type of sine function all put it together. So Fourier transform is probably like one of the highest level class in physics, one of the hardest class. So you're gonna take. I never take it because I'm not smart enough, but some of you guys will. You see how crazy this is? It's built by basic sine functions. It's combination all different kind of sine function, put it all together. There was actually very great question. There was, if you could give him a diagram, they can take that diagram and translate that to a mathematical function. And there was a computer software can do that directly. It's not even like, but the people who invent that program is amazing. But basically, you can describe about anything. That's why people can imitate people's voice using AI. Right? If I want to say a phrase like in terms of Taylor Swift's voice, I can do that. So yeah, so this is a very start basic of this, but start by using a basic sine functions in terms of circles. But later it's going to be multiple different circles all combined together. But this is the first. I don't know how to say it perfectly. Sinusudograph, or I don't know how to say it. Those of you guys that get pronunciation can probably teach me how to say it. It's sinusoidal. Yeah, sinusoidal functions. So basically, I'm just taking the y value of the unit circle, and I take that just based on that and graphing according to it. So this is how I generate all the sine graph, and so that's a basic sine graph. Now here's my question: if I were to do cosine graph, what would be the difference between cosine graph? You're gonna take the distance for x, but what will be the very beginning value? What's the y-intercept in that value? Yes, 1. So the sine graph and cosine graph, if you really pay attention, that if I take this function and I say, hey, let's figure out what a sine graph look like. Sine graph is going to be like this. And the cosine graph is going to start at 1 rather than so this start at 1. You start at the highest point and start going down. It's oscillated the same way because you're taking the horizontal displacement between the point and the y-axis. Does that make sense? The point and y-axis, you take that value, you're going to get a value. Okay. So far, you guys okay? Now, we're going to talk about this. Now, in terms of this, the only value I really use in terms of graphing, I only use this value, this value, this value. I don't use anything in between because I know it's going to oscillate in between 0 to 1. Okay, so obviously I'm going to plug in 3 pi over 2 here. I'm going to plug in pi. And there's all the value in between, of course. But it's going to be -1. And this is going to be 0. And that's how you get those two points here. And you create this beautiful sine graph. Is this okay? Now I'm going to talk about sine graph and cosine graph. So I'm going to just use 4 different values instead. So y equal to sine of x. If I use a few most important value, let's just say x and y, it could be 0, pi over 2, pi, 3 pi over 2, and then what? 2 pi, right? So we know at 0, I'm going to get 0. At here, it's going to give you 1. At pi, it's going to give me 0. At this is going to be -1, and then go back to 0. So the graph based on this. So this time, I'm going to use some simple values better. So this one is going to be pi over 2. And this is pi. This is 3 pi over 2, and this is 2 pi, and this is 5 pi over 2, and this is 3 pi, and this is 7 pi over 2, and this is 2 pi, no, 4 pi. So the value is going to start here, 0, 1, 0, negative 1, 0, positive 1, 0, negative 1, 0. So this graph is going to be like this. Now, I don't care about any smaller value. I only care about when they get 1 and negative 1. Sure. And this is a sine graph. Is this okay? 3 pi over 2 to 2 pi, and then 5 pi over 2 to 3 pi, and 7 pi over 2 to 4 pi. Yes, that's because you just add pi over 2 each time. Now let's talk about something else. The distance from here to here, there's a name for that. This is called an amplitude. There's a name for that. It's an amplitude. How high from the midline away. So this is also known as a midline. So I'm going to change here. This is the purple part is called a midline. It's a midline to the peak, or midline to the trout. That's going to be known as an amplitude. Am I going too fast? This is an amplitude. So it's from the middle to the highest peak. Are you following me so far? Or the middle to the trout. So this is also known as the maximum. This is known as the minimum. But in terms of sine graph, we're going to call it peak and trout. The lowest part of the wave, or the highest part of the wave, we call it peak. There's something else we need to know more. The distance from here to here this is known as the period. Period, that means you go through a whole cycle. From the midline, it go in once, and the second time you hit the midline, that is the period. The period is when the sine graph go through the whole cycle. Is that okay? The distance from here to here. Now, sometimes it can be determined by this way. Some people says, hey, can I just look at a peak to peak? Yes, peak to peak is also a way to determine the period as well. But is that same distance? Same distance, right? It's peak to peak. Or it could be trout to trout. This is all the different way to describe a period. From peak to peak, or trout to trout, or midline cross the second time to the midline because you go through the whole cycle.
Trout like the fish, or how do you spell that?
Trout is like T-R-O-U-G-H, right? Did I spell right?
Yeah, trout. Like horse trout.
My pronunciation is bad. Sorry. I wish I'm white. No, I'm not. But anyway. Is that okay? So you can decide from peak to peak. You can look at a measurement from peak to peak, which is the highest part of the graph, to the other highest part of the graph. Or the trout to trout, that's another way to determine period. Or the midline. Midline, you had to go through it twice. The second time, it's going to go back. Because if you go through the first time, that's the only top part. It's called half period. And the bottom part is another half period. So 2 half period after you hit, it's 1 whole period. Yes, Sophia?
I can't read that, Mr. Good. It's like above minimum.
Okay, which part can I read?
Like above minimum.
above minimum is amplitude. Is this distance from here to here is called the amplitude. This is amplitude. And this is also known as amplitude. Amplitude is from the midline to the peak, or midline to the trough. Are we okay here? Okay. Now, so the period is how far? In this case, normal sine graph, what's the period? 2 pi, good. 2 pi is a period of sine of x. Is that okay? In this case, amplitude is 1. Now let's talk about cosine of x graph. Cosine of x, I'm going to give you 5 simple values. You can tell me what's the output of this. I'm going to start with 0, pi over 2, pi, and then 3 pi over 2, and then 2 pi. Can somebody tell me cosine of 0? Raise your hand if you think you know. Yes, Amelia? 1, good. What's cosine of pi over 2? Sophia? 0. What is cosine of pi? Anybody else? I know Sydney. -1, good. What is sine 3 pi over 2? Kusnia? Good. Alex, can you tell me what's cosine of 2 pi? What? 1. That's perfect. So therefore, I'm going to start with a graph, cosine of x graph. I'm using 2 space to represent pi over 2. So I'm going to start at a peak, which is 1, because at 0 is 1. At pi over 2 is going to be what? 0. Is that okay? At pi is going to give you -1. At 3 pi over 2 is going to give you this. And here is going to give you pi. So it's going to be like this. So the graph's not a straight line. It's curvature. Some people do like this. That's bad. This is bad. That's not right. So its curvature is like this. For cosine graph, look in one period, look kind of like a base. Kind of like a base, like this. Now, of course, I can grab 2 periods as well. So this is first period from peak to peak. So this is a period again. I can grab a second. They pretty much just reciprocate itself. That's the second period. Because again, that's a peak to peak. So the only thing difference is cosine start where? At peak. At the highest point. Sine graph start at a midline. So I will write this down, just kind of help you. Sine x start at midline and go up. Negative sine of x is reflect. Start at midline, go down. Does that make sense? If you have negative sine of x, you start at 0, it's going to go down. Go to the trough first. Cosine x start at peak. If you have cosine of x. If you have negative cosine of x, start where? Trough. It's not a fish. So if you have a basic understanding that, it's good. Now you must go to the midline and go down. So you cannot go from the peak to the all the way down. That's what people always have problem with. So for the next thing is we're going to show you what will be the standard form. Y is equal to A sine of B x minus C plus D. You look like, oh my god, this is crazy. A, B, C, D.
Wait, no, scroll up a little bit. Is that a pi or 2 pi?
You're right. This is 2 pi. Thank you. Thank you for fixing that. Okay, y equal to a sine b parenthesis x minus c plus d. I'm going to tell you A stand for. A is going to give you the amplitude. D is going to give you the midline. B is going to give you the ideal period. But it's actually 2 pi over B is the period. C is your horizontal translation. Horizontal translation. D is also the vertical translation. And it's going to give you my lows. I'm going to start with graphing a simple one. Let's just say we want to graph 2 sine of 2x. We're going to graph this. First of all, you got to be able to tell what's the amplitude here. What is the amplitude? 2. So you're going to write down amplitude is equal to absolute value of 2, which is 2. Why is absolute value? You could have -2. You're going to do absolute value. That's still going to give you 2. The amplitude is only positive. It's the distance from the midline to the peak or distance from midline to the trough. Second, I need to be able to tell what is a period. What would be a period in this case? Yes, because the period in terms of sine and cosine is going to be 2 pi over b, which is pi. Are we okay here? Now, I will tell you that this is going to help you is to find the quarter period. Quarter period is the other major change. So let's just say 1/4 of period is going to be pi over 4. We're going to take this divided by 4. So I'm going to start graphing.
Why is the period pi?
Because it's always 2 pi over b. In this case, b is 2. See, this is 2. Because this is b. So it's always 2 pi over b. Because the period for sine is 2 pi. But since the b is going to give you a horizontal compress, by the way, you're going to compress this way. It's going to increase the frequency. So that way, this is going to be, well, I'm going to say this is going to be pi over 4. This is going to be 2 pi over 4, which is equal to what? Pi over 2. 3 pi over 4. And 4 pi over 4, which is pi. Is that okay? And this is a 1. This is a 2. I'm going to use that 2 space so I can see that. So that means the period is going to start right here, end with here. But every quarter period is going to cause you a major change. So every quarter period is going to go to the peak. You start midline, it has to go to the peak, right? Peak has to go where next? To midline. Good. Is that okay? And then to trout. And then go back. And there you go. This is 1 period. And then you're going to do it again because usually I'll ask you to grab 2 periods. Oh, sorry. This should not be that far. So it should be right here. 4 units, so it should be here. Now they are not straight line, so this one is gonna be 2 pi, 3 pi. This is 5 pi over 2, and this is 7 pi over 2. And there we go. I grabbed 2 periods. Because pi over 4 plus pi over 4, because so imagine you have a quarter, right? So it's pi over 4. And if you have 2 quarter, it's a $half, right? Because that's 2 quarter, it's a $half, so it's pi over 2. Or you can say 2 pi over 4. You can say 2 quarter out of 4. And you can say 3 pi over 4. So you just add each time, you add pi over 4 each time.
Then you just be like 5 pi over 4?
5 pi over 4 for which one?
After you do pi. Pi is 4 pi.
Oh, no, yeah, you're right. Damn, I can't add. 5 pi over 4, I'm so sorry. I wasn't paying attention. So this one is going to be 6 pi over 2, so it's 3 pi over 2. Is that all right? 7 pi over 4 and 2 pi. Thank you so much. All right, twice. Yeah. Now remember, cosine is going to start at a peak. Or negative cosine is going to start at trout. So today you're going to graph 4 different functions for me. That's it. So I'm going to start with the negative 3 sine of half x. 2 cosine, yes. 2 cosine of 3x. And negative 2, sorry, is going to be 4 sine of 4x and negative 2 cosine of 3 over 2x. So we're going to try to graph this. Only 4 questions. You got to try your best. Huh? What'd you say? This one I can take it on the picture on the group chat.
Did you see?
Yes.